A PCB drawing defines a nominal target, not the finished physical structure. After fabrication, dielectric dimensions, conductor shape, and via relationships can differ slightly from that nominal model. That variation can be normal within agreed limits. Within tolerance does not mean defective. The artwork captures two-dimensional design intent, while the stack-up defines a nominal target for the board. Manufacturing turns those inputs into a three-dimensional physical structure with finished materials, conductors, and interconnects. Approved tolerances describe the permitted range around each intended dimension. Finished dielectric thickness changes the relationship between a signal conductor and its reference plane, depending on the actual construction. Etching and plating shape the finished conductor cross-section, so nominal line width alone does not define the final geometry. Those physical relationships can influence electrical behavior. The engineering significance depends on the application and remaining design margin. Registration describes how the actual layers align, not just whether individual features meet their own drawing limits. The finished relationship among the drilled hole pad and anti-pad can change when their positions shift together. Relative position matters because it contributes to the final physical interconnect structure. Finished hole geometry reflects the completed connection, including the physical hole and plated wall. For a Microvia, the actual landing relationship determines how the vertical connection meets its intended copper target. Backdrill depth changes the remaining via geometry and should be evaluated against the project's defined requirements. RF structures can be sensitive to the finished conductor and surrounding dielectric relationship. High-speed channels can respond to interconnect geometry, reference relationships, and transition structure. HDI connections emphasize the physical alignment and geometry of dense vertical interconnects. The same manufacturing variation can matter differently across different applications. A small dielectric shift can remain inside its permitted manufacturing window. A separate conductor geometry shift can also remain inside its own agreed limits. Via or pad position may change independently while still meeting the applicable positional allowance. Together, those individually acceptable changes create one final physical structure that differs from the nominal drawing. Several small variations can combine. That does not automatically mean a defective board. Apply the same physical shift to two otherwise different design contexts. A design with more available margin may remain comfortable, while a tighter margin design deserves closer engineering review. A tolerance window defines the target and the agreed lower and upper acceptance limits. Actual process behavior describes where produced results are centered and how they spread. A stated tolerance and demonstrated process capability are related, but they are not the same thing. Engineering control aligns design margin, process behavior, and acceptance criteria. The goal is controlled variation, not zero variation. Explore PCB manufacturing capabilities.